And we're live. Good morning, good evening, good afternoon, everybody. Again, it's morning here, so I got my coffee and I'm super excited, but I'm a little sad too because we're coming up to the end of our conference series. This is the last day. Bruno's going to give us the second last talk in our series, which has been info packed. I've been super excited every time we do one of these. And you can check them all out. They're all on our Crowdcast. Giving us a follow or checking our channel, you can go back into our archive and see all of the amazing talks and workshops that we've had. But today we're about to jump into the final two, and in this one we're talking about querying past data on a substrate chain and the different ways that you can do that. So it's going to be very interesting, a little bit technical for you folks, but it should be elucidating for all. So I'd like to welcome Bruno to the cast. How you doing, Bruno?
Hey, doing real well. Thank you for having me again. It's a pleasure to be here.
Yeah, no, it's great. It's great to have you again. I really enjoyed our last talk. And as usual, I'd like to get to know our speakers a little bit better before we dive into the meat of the presentation. And so last time I asked you a more general why you got into the blockchain space, but I wanted to drill down a little bit more and ask you why you got into the Polka Dot space.
Yeah, so I used to work in Ethereum 2.0, and that was interesting and challenging. Polkadot seemed interesting. I mean, I transitioned for a host of reasons, but Polkadot got my attention because it's kind of I like to call it the tide that'll float all boats, because it's like whatever you do on Polkadot, you do to all the connected chains. So if you connect one chain to the entire ecosystem, you end up giving that feature of that chain to all of the chains that are connected to it. And I think that's kind of a big deal, being able to, because right now Ethereum is doing really well on the DeFi front, but that's going to be a little bit more fragmented once Ethereum 2.0 comes out, because the contracts are going to be scattered around through the different shards, and you're going to lose this atomicity of transactions. You won't be able to call upon 30 different contracts in a single transaction that easily anymore. And so now you have this asynchronous communication going on a fairly scalable network. But if it's already asynchronous, then it kind of feels like you've been boxed into a feature set that is limited by the Ethereum virtual machine. And on Polkadot, you get that same asynchronous communication across any kind of shard that's connected to it, so any type of chain, including Ethereum 2.0 when it connects to Polkadot. But then you also get this ability to connect different feature sets of different chains and talk to them and get them to talk to each other, which I think is a much bigger deal. Being able to get Bitcoin into Ethereum's DeFi, being able to mask transactions on both of those with Monero's private transactions, being able to focus on NFT use cases in a single chain and then using those as collateral in either Ethereum or Bitcoin spaces. And there's so much undiscovered ground here that I think it's just reasonable to be excited about it.
That's amazing. Yeah, I think it's quite reasonable to be excited about it as well. I've heard like the analogy drawn for the Ethereum space that the shards will be like different boroughs, and there'll be like a Manhattan borough and the suburbs borough, and that Manhattan one will be a lot more expensive. And I think that's where it sounds great on paper, it still seems like a little prohibitive. So I agree with you. I like the open aspect, the raising tides of all ships that Polkadot kind of represents. Super cool. So I know that you keep your ear to the ground with the news in the Polkadot space, and you put out a newsletter roughly weekly called .leap. So for those that don't already subscribe, I highly suggest you go and check out .leap and subscribe to it. But for those that aren't already subscribed, give us a little nugget of information, like what's happened recently in the Polkadot space that somebody might find in your newsletter.
So I try to make .leap as comprehensive as possible, so you'll find everything in there for all walks of Polka Dot ecosystem life. So you don't have to be a developer to kind of understand or appreciate a newsletter. It will cover governance protocols, it'll cover protocols changes, it'll cover votes, it'll cover everything from the soft skills like council members voting on things or making decisions or participating in discussions, to hard technical upgrades like core updates and new pull requests that got merged and so on. So I like to cover everything. Mainly, I started it mainly for myself because I realized that it's very difficult to keep track of things, and there wasn't a unified resource. And now I find myself often just Googling with a site limiter on Google. I just limit it to the newsletter, enter a keyword, and it turns out I kind of mentioned it somewhere in some issue, and I immediately have a link. So that's super useful. In terms of just last week's cycle, and I do really try to like fill up every newsletter edition to the brim, so there's content for everybody. We have the release candidate version of Ink. That's the programming language for Substrate-based chains that's native to Substrate, and the alternative to Solidity and the EVM versions of things. I also have a Ethereum compatibility section where I will document meticulously what is happening on the on two very important fronts. One is Frontier, which will turn any Substrate-based chain that has the EVM built in into an Ethereum-like node, and that basically means that any chain that has this built in will be able to interact with MetaMask, Ganache, and all the typical Ethereum tools. And the other is Moonbeam, which is actually the already deployed copy of Ethereum on Substrate. So I covered the news there. So if you're still an Ethereum diehard, you can expect to have a home on Moonbeam and these compatibility layers in Substrate and in Polka Dot ecosystem, because Moonbeam will be a parachain. So again, staying on top of news in regards to that is very easy with Dotleap. And then there's just interesting tools that I discovered that don't have anything to do with Parity or Web3 Foundation, but are created by the community or by developers, or just randomly I ran into them. Like, for example, I just recently discovered an integration of IPFS and Substrate on a native level, which means that you can get a Substrate node, so a Substrate blockchain, which has IPFS built in, and that lets you save and grab and pin files from IPFS during the block processing operation of your blockchain, which means you can essentially build a blockchain that can store large amounts of data into IPFS without worrying about bloating the state size, and that's all built into that. So yeah, newsletter.dotleap.com is where you can find out more. And of course, if you have any suggestions to throw at me, I'm always on Twitter or email. Send me your links and I'll make sure they're included.
That is amazing. And yeah, I just asked for a little nugget, and that was so much information, which I appreciated. But that really was just a little nugget. Like, I'm looking at the newsletter here right now. There's so much here. I try to get through it all, but like it's dense and it's amazing. And one of those pieces of information that really stood out to me is that Bruno is running for council on both Kusama and Polka Dot, right?
Yeah, that's correct. So Kusama and Polka Dot have this council governance body where a few 19 people on Kusama and 13 people on Polka Dot are elected as people who have the best interest of the chain in mind. And those people have a little bit more stake in the system, in that their reputation is on the line along with their money in terms of tokens. They're not paid for this position, but they are just very enthusiastic about driving the chain in the right direction. And so the council has the ability to decide on treasury spending proposals. So when somebody wants to get a treasury grant to develop something, the council are the ones who develop it. The council will also approve bounties and tips, which are also spending mechanisms for the treasury, and we use those regularly. The council has some other abilities, like pushing out referendums that are biased towards passing. So because these people are kind of have this best interest of the chain at heart, their proposals that they make in terms of upgrading the chain are deemed useful by default, and therefore have this little bit of extra trust in that group of people, that they know what they're doing. So in order to reject a council initiated proposal, the community would have to submit more nay votes than aye votes to fail it. In public referendums, that's the other way around. So they are default to failing, because this is a spam prevention method. And then if the majority votes yes, then it will pass. With the council proposed ones, it's reversed. And I do run for council in both Polkadot and Kusama. I am currently in the active set of the council of both chains. This is, I believe, in part due to .leap, because the readers have voted me in, which I appreciate a lot. And in part because I submit regular transparency reports. So whenever I vote on any kind of decision, cast any kind of vote, I will document it in a blog post and push it out so that everybody knows what I'm doing when and exactly why. If you want to vote for some council members, you can just go to the council part of the Polkadot UI, which I'll link in the chat later. And there you will find a list of runners-up and current council members. The voting doesn't cost you anything except a transaction fee. So you can use this method to kind of help somebody you appreciate or want to give a chance to prove themselves in the council and to improve the chain. This is especially useful if you think some council members are kind of dormant or inactive and you want them out. Just endorse somebody else, and eventually the sleepy ones will get voted out.
Yeah, so can you like highlight how that works? Like there's a limited number of council members, right? So if somebody becomes dormant, like you can take your vote away from them and give it to someone else, and at some threshold they'll get bumped out, a new one will get bumped in. Is that how it works?
That's pretty much it, yeah. The algorithm that decides who gets in favors multiple smaller votes over big whales voting for candidates. So while it's technically possible to vote oneself into the council, it's very, very difficult to vote oneself into multiple seats. Because if you have this whale, you would have to distribute the funds into many different seats and then vote from those in separate parts. And by then, everybody else has voted in a much bigger percentage for other people on the council. So yes, by removing your vote from some people and then adding it to others, you have the chance to push those ahead and get them into the active set. Yeah.
Very interesting. One more follow-up question on that is there, like, I guess that is also that limit is also fluid based on a council vote, right? So eventually, as the network grows, it's possible to increase that amount or potentially decrease it. Is that correct?
Yes, that's not the council's decision though. The community will decide on that.
Right.
The council can propose that change, or the public in general can propose that change, but it's all the dot holders who vote for this change to be enacted. So if we do decide to upgrade the number, then it will be a public referendum. It'll take whatever it needs to take depending on the chain. So 7 days on Kusama or 28 days on Polkadot. And if it's voted in, then it will be automatically enacted, and the active set will be increased when the time is right.
That is super fascinating. I love this concept of a decentralized autonomous organization, and it's happening before our eyes. We have on-chain governance, we have a council, both on Kusama and Polkadot, and you can go and vote for Bruno. I know he's got my vote. I love his newsletter, and I love how he really represents transparency. So that's awesome. I think we're going to jump into the talk, but before we do that, I just want to mention to the folks that are watching, there's an Ask a Question button. So if you have a question for Bruno as we're going through the presentation, please use the Ask Question button. If there's a question that you really want to get answered, give it an upvote. Right beside that, we also have a polls button there. So I wanted to know if you guys already knew about .leap and if you subscribed. And sadly, nobody had heard about it before, but now they're going to go and subscribe. So that is encouraging to see. And I wanted to also know if you were running a full node or an archive node on any blockchain. And we have quite a few full node runners. And then we also have 33% have not yet run their own node. But, I think eventually everybody will be more incentivized to run their own nodes. It only makes sense as these systems become bigger. becoming a full member of the community means participating in some kind of way, at least in archive nodes, so that that information is always there. And it's always great to validate your own blocks. That's super cool. Okay, so I think we're going to jump into the talk now, and I'd like everybody to help me in welcoming Bruno to the cast. You've seen him before, but to refresh your memory, Bruno is a blockchain developer and an educator from Croatia. He joined the ecosystem full-time in 2015 and has worked on one of the teams building the next generation of Ethereum. And since 2019, he's been a technical educator for the Web3 Foundation. Bruno is passionate about decentralization, censorship resistance, and transparency, coupled with accountability, as we could see through his .leap newsletter and his council member seat. He holds a master's degree. He holds master's degrees in computer science as well as English language and literature, and has he also runs a weekly newsletter, as we know, called .leap. So I'd like everyone to help me in welcoming Bruno with a nice digital round of applause. Welcome, Bruno, and you can take over the cast.
Thank you. Let me just share my screen here. Okay, so I have on my right the chat open. So if the chat and the question box open. So if at any point you have any questions, just shoot them into the box, and I'll do my best to pause and answer them. I like to answer questions as we go along, because people tend to get hung up on their question if they don't get it answered and stop paying attention. So I like to cover that as soon as possible. So today we're going to briefly chat about reading past data from Substrate chains and in general how they store this data. It's not as technical as it could be, and I tried to keep it very abstract so that it's understandable to most people. And we'll finish up, if there's time, with a short demo on grabbing some of this data from the past, and maybe we'll also check out grabbing data from the present. So let me start this off. Okay. At any point, if something breaks, if you don't see the screen anymore or don't hear me or something, just say it in the chat, and I'll see it. So my name is Bruno. You can always contact me on Twitter or Telegram or LinkedIn or email. Email is just bruno@web3.foundation. And I will be happy to answer any questions you have about this topic today, Polkadot in general, Substrate, whatever you wanna talk about. If you want to talk about your project making sense on Substrate or your project connecting to Polkadot, I will do my best to cover everything from reasons to why to reasons to why not, and what you can offer, what you can get by doing this. I really don't want to sell a tech stack to people just for the sake of selling the tech stack. I want it to make sense to you and to your business case or use case. So please feel free to reach out at any point. So if you weren't here during your last crowdcast that I did, we have to start with Substrate a little bit. So Substrate is the framework for building blockchains, and Substrate is like this really battle-tested foundation on which you can build your blockchains. Substrate comes with its own networking layer, the database, transaction queue, and the consensus layer. So stuff that you would expect every blockchain to have, but that projects usually spend a year researching before they develop their own blockchain. Substrate comes with that out of the box. And by building on Substrate, you have access to the frame palettes. And frame palettes are, so frame is like this framework for developing these palettes. And you don't have to remember these names at all. They're a little bit confusing when you're first encountering all of this. So just remember that any Rust program has modules, and these modules just bring in extra features. So this is like in any programming language, right? These are just libraries that you pull into your program and then use the code that somebody else wrote. In Substrate, those are called modules, and in Rust, those are called modules, and in Substrate, those are called palettes. So palettes bring extra functionality to your chain. They're very chain specific, blockchain specific, and you pull them in depending on what you want your blockchain to do. In this case, in this illustration, for example, I have the foundation that is Substrate, and then I can pull in the governance module, the governance palette, and the balances palette. And once I plug those in, I have, through the balances palette, I have the basic functionality of a cryptocurrency, so sending, receiving balances, and so on. And with governance, I have the ability to issue referenda on the chain so that the chain can be upgraded, and so that some parameters can be changed, and so that other people can vote on these changes. So this is the point behind democracy. So these two palettes can just be plugged into Substrate with some caveats. So you need to modify some configuration files and just include those as dependencies, yada yada, recompile. But once you do, you end up with a fully custom blockchain, and Substrate lets you build custom palettes as well on top of all this, which have fully custom functionality. So you don't have to rely on this ready-made set of palettes. They are a handy shortcut to some of the most popular functionality, and most of them are actually live and deployed in Kusama and Polka Dot. Kusama and Polka Dot are in fact Substrate chains that just are composed of these different palettes. So, but you can also develop these fully custom palettes that make your blockchain very application specific, and that's the key selling point there. You can specialize and optimize your blockchain for a specific use case that simply cannot be done in any other blockchain system that currently exists. You will always be in other blockchains forced to use their architecture and forced to use whatever constraints they have on their platform, which in most cases might work fine, but in some cases you just need that application specificity that you cannot replicate otherwise. So Substrate Runtime, like I said, is composed of many different palettes, and these are then compiled into this one common runtime. So in this example, we have some of these palettes. Now this is not a comprehensive list. This list is much greater. But from this list, we've picked a few of them. So baby balances, grandpa indices, pseudo timestamp system, and we have sorry, let me just move this out of the way. We have composed the runtime out of these palettes, and the runtime just takes them and churns out a binary file that you can run, and this binary file will have the functionality of all of these palettes. So for example, the timestamp palette, the only purpose of this palette is to write into each block that gets produced by Substrate the timestamp when it was produced. That's it. So every palette is very application specific in its own. So you get this very granular functionality that you can just drip into your blockchain for very specific use cases. So timestamps let us know when a block was produced. Balances allow us the basics of cryptocurrency. Grandpa is for finalizing blocks. Indices let you register an address in a shorter format, and so on. There's also the concept of metadata. So every Substrate blockchain that we develop has this automatically exposes metadata. So you have this data that you can plug into with a Substrate chain with different RPC calls to the node, and the chain will talk back to you with information that you requested. But there's also the metadata layer. And when you're building the Substrate runtime, when you're compiling it, all the code documentation, everything that is documented in the Rust code with / comments and so on, all of that, along with every single function, module, call, absolutely everything that your chain can do, errors, events, anything that it contains, the full description of the chain will be composed into a JSON file and output as metadata. And you can always grab this metadata from a Substrate chain and use it to find out these meta contextual information about your chain. For example, if a chain has the timestamp palette, that will be listed in the metadata as an included module. If it has another custom palette and that palette takes certain arguments and certain functions, all of that will be listed there. This has the benefit of letting you find out about your chain without reading the source code. So the chain will tell you about itself. And this lets you have different custom UIs that we talked about last time, which can automatically configure themselves to look different based on what the metadata provides. So if you go to the Polka.js UI, you will actually, let me demonstrate this real quick. So if we go to polka.js/apps, polka.js.org/apps, why is it asking me for, come on. We are connected to a non-live network. Let me just connect to Polkadot. There we go. So we're now reading events, reading the blocks from Polkadot. And you can see here that, for example, under network, we have Explorer, staking, and event calendar. And under developer, we have 5 items: chain state, extrinsics, RPC call, sign and verify, and JavaScript. So that's Polkadot, right? These options are all different palettes. So this is the democracy palette is a palette, the treasury palette is a palette, and so on. So now let's switch to Kusama. And you'll immediately see that under network, we now have another option called society. Let's see what that is. And this is a DAO, so a decentralized autonomous organization, kind of, which lets you, well, in a nutshell, it lets you get a tattoo of the chain, and if you do, and you submit proof of ink, you will be entered into the society and get this reward from the pot. So basically, it's a DAO that pays you to get tattoos of the Kusama chain. Don't ask. And then let's check out this one, Edgeware. If we switch to this one, we will get, under developer, we get the new option, contracts. So we now have access to smart contracts. Smart contracts do not exist on Polkadot or Kusama, but they do exist on Edgeware. And since this is all the same UI, it has automatically configured itself based on the metadata provided by the chain we have connected to. And that's the power of this metadata. Question, do you have a Kusama tattoo? I do not. I've been pretty much against tattoos all my life because, you know, permanent regrets and stuff. But 999 KSM sounds appealing enough to me to break that promise of mine to myself. And if the pot grows to this amount and the community, because the pot, when it grows, it will automatically on every spending cycle include as many deposits sorted by amount from lowest to highest, include as many as it can into the next distribution. And then those people have to produce the proof of ink. So in order for me to get included with my 999 KSM bid, the pot would have to grow significantly. If this happens and I am indeed included, I will get a Kusama tattoo. Very slim chance of that happening, but hey, why not? Let's see. So this is how the metadata helps us automatically configure the UIs that our chains are using. And like I said, both Kusama and Polkadot are based on Substrate. They have their own palettes added. So you saw the difference. Kusama has the society palette with the tattoos and stuff, and Polkadot doesn't. This is because Kusama is more playful, chaotic, and definitely more accepting to these edgy use cases that maybe don't have a home in the more conservative and slower to move Polkadot network. Kusama is also different in that it has a shorter time period applied to major decisions, events, and so on. So these are mostly 4 times faster than in Polkadot by and large. For example, if the community votes for a referendum, on Kusama it'll take 7 days for that to get enacted, and on Polkadot it'll take 28 days. This is done because, you know, Kusama's edgy, has a more active community that's more frequently interacting with the chain, but it is also more prone to doing these hacky experiments. And Polkadot people will be more passive. Let's say it like that. They will be more interested in you know staking their money and not exactly checking in every day, looking at the UI, what they can do or should do. So it might take a while before people even notice different referenda popping up. So now let's talk about the different types of nodes we have in blockchains in general, but also this applies to Substrate. So the lightest version of these are light nodes. And light nodes don't generally store any data about the chain, except they can verify the latest chain, and they can provide you with the latest chain they have. They have to connect to another fuller node, which we'll cover later. They get the data from that node, and they can verify that the node is indeed okay, that the data is indeed okay, and they will forward that confirmation to you. You can also use light nodes to send transactions through them to the network. But light nodes are not standalone nodes that are enough to secure a network. Light nodes are very useful for embedded devices, low resource devices, and even browsers, because Substrate compiles the runtime into both binary mode, which you can run locally as your node for your blockchain, but also WebAssembly, which gets uploaded onto the blockchain itself. This WebAssembly can even be uploaded separately into the browser and interpreted with JavaScript. What that means is that you basically get a program that you can stick into a web page, and that web page becomes a light node of Substrate. And we actually do have a proof of concept implementation of the Substrate light node for running in the browser. If you go to the Substrate repository, you will find there, I think it's in the browser folder or something like that. Tests are already there. You can just compile it and try running it. It's far from optimized. It's huge. It takes a while to load. I think it takes I don't know the size off the top of my head, but it's not optimized. It's just a proof of concept that a in-browser node actually works, and that it can be compiled, and that it runs, and it does what you expect it to do. It will connect to the chain, and it will be able to interact with it. The second type of node is a full node. So that's much heavier than the light node, and the full node is what most people are running. So the full node, and this is kind of counterintuitive, but a full node doesn't actually have the full data of the blockchain. A full node has the current data of the blockchain, which is also known as the current state, and it can always tell you about the information stored on chain right now. If I ask for my balance, the full node will be able to tell me. But if I ask for my balance at block, I don't know, 100 blocks before today, before the most recent one, it will also be able to tell me. But if I ask for 1,000 blocks before the most recent one, it will not be able to tell me. This is to conserve space. Saving all the changes of the blockchain as they happen takes a whole lot of space. And additionally, full nodes store some other information that isn't actually, I mean, it depends on how essential different parties see it. But a full node will also store all the extrinsics, and extrinsics are external inputs to the chain that cause some kind of an effect. So basically, these are commands to the chain. When you have a module, a pallet, and that pallet has some function and takes some argument. When you submit that function and provide that argument, you have created an extrinsic. And when the chain gets wind of that extrinsic, it will react to it. It will change the state to the new state that is affected by that extrinsic, and it will emit an event, usually, that describes what happened, why, and by whom. And so these extrinsics are the drivers of the chain, of the change in the chain. So they are commands that are causing these state changes of the chain itself. And the full node will store those from Genesis, from block 0. This takes up a lot of space. So if the full node were to store every single, not just every single extrinsic, but also every single event that was the result of that extrinsic, and also every single intermediate state that happened because of that extrinsic. So for example, we have block A, then an extrinsic comes in, we have block B and the state in block B, then an extrinsic comes in, then you have block C and the state in block C. A node that will store all three states and extrinsics and events would take up a lot of data. So full nodes prune or clear or delete everything older than 256 blocks. Everything older than, yeah.
Do you have something showing on your screen right now? Because right now we see like 2 leaves and like a weight.
Yeah, that's fine. That's it.
Okay.
Yeah. So the what was I saying? Sorry. The full node will actually prune everything. It will delete everything older than 256 blocks in an effort to conserve space. It's just not going to bother with all of that old stuff. It knows that the data that most people care about is the current state. So what's the state of the chain right now? And it still has the ability to read into the past because it did store all of those extrinsics. And now the final node is the archive node. Now the archive node actually stores all the intermediate state changes. So it will store the state as it was on block A, the state as it was on block B, the state as it was on block C, from Genesis to the latest block. And these take up a lot of space. In Ethereum right now, I think it's something around 5 terabytes of space to store the entire archive state of the blockchain, and you need that on an SSD. So a 5 terabyte SSD needed for archive data. There's an effort called TurboGeth which has compressed that down to I think 800 gigabytes, which is great, which is much better. But yeah, that's the famous state growth problem of Ethereum. It's growing like crazy, and every chain has this. So every single chain has this same problem. If you want historical data, it is really technically difficult to pull it off, or expensive, because not only is that a lot of data, but when you're writing and reading this data as your node is when it's running, it's bombarding your hard drive with a lot of different random reads and writes, and even SSDs have trouble surviving that. So this is why different people are now experimenting with different formats of these databases, so that these lookups can be more structured and they don't have to, absolutely destroy these hard drives like that. So an archive node is the full node that you want to have if you're doing some kind of past auditing. If you have a tax calculation tool or whatnot, there's actually a really cool one that's integrating DOT and KSM soon. It's called Rotki. So let me just put it in the chat, Rotki. So that's like a portfolio tracker, but that connects to everything you can imagine, to Bitcoin nodes, to Ethereum nodes, to centralized exchanges. It pulls all of your information historically, stores it on your local hard drive. Nothing goes through their servers. They have no servers. It's a fully local app. It will pull in all your information from these archive nodes on different blockchains, and it will calculate exactly how much you owe in taxes depending on jurisdiction, based on the price fluctuations over time and the state of the blockchain at certain blocks in those times. And that's why having these archive nodes is very important. These tools cannot work without archive nodes. Also, different blockchain explorers cannot work without archive nodes. If you look at past blocks in an explorer, like for example, let me just here. If you look at past blocks in an explorer, like the one we just took a look at a little bit ago. So Kusama is on block 4.7 million, but we can look at block 1 million, so that's 3 million blocks into the past, and we still have the information about that block. We still know what happened in that block. And this is because when we connect to Kusama, this endpoint that we are connecting to, that's Kusama rpc.polkadot.io. This is the public node hosted by Parity. This is actually an archive node. So they are keeping an archive node publicly available for everybody to connect to. And this is the default of what the Polkadot.js UI uses. And this is why it has this old archive data. So we can see all the extrinsics that happened and all the events that happened in that block as well. And also who mined it, who created the block. And you can also see this block in explorers like PolkaScan. So PolkaScan also is PolkaScan is doing another thing that I'll talk about a little later. PolkaScan also has all of this information. But what PolkaScan did is they are not reading from a Kusama archive node. Instead, they are grabbing, they are using a Kusama archive node, but they are crawling the entire database of the Kusama chain, and they are resaving that data into their own PostgreSQL database. So they are saving the information into a more linkable, human-readable, and interactable format than the state tree mess that is a blockchain's database. And so the reason why they can do these quick lookups is because they've actually taken the data from the chain, saved it in a different format, and they're now querying that data. Obviously, this is ultra centralized, right? So if PolkaScan's servers go down, the entire Explorer goes down. But this is not important for blockchain explorers because we never really expected them to be decentralized. You can always connect to your chain directly and read this information. You can also always run your archive node directly and connect to that with a local copy of the Polkadot.js UI, and you again get all of this same information. So that's what archive nodes are. Now, a light node can never become a full node, but a full node can become an archive node. That's an important distinction. So a light node will just check that the data provided to it by a full node is legit. And this is how it can serve as a trustable client that you can connect to the blockchain through. But it can never be a full node, because a full node implies that the program can rebuild the chain from scratch. And so how can a full node become an archive node? Well, remember we said that the full node has all of the extrinsics ever stored, ever submitted from day one, from block 0. So all the extrinsics are saved. And we also know that we had a certain metadata of the chain when the chain was launched. We know what the metadata was. It's enshrined in the Genesis block, in the first block. So if you put those together, you take the metadata and you know which functions exist. And then you take the extrinsics in block 0 and you apply those through the metadata to the first block's state. And so the state change that is the result of that will be the new state. And since you have the metadata, you know exactly which functions and methods in which palette emit which events. So you can also replay the events. And when you did that, you have successfully recreated the state at block 1. And then you do the same thing in block 1. You now have the new state, you apply new extrinsics to that, you follow the metadata format that you were given, that you already have from before. Again, you emit the events and you follow along and you keep building. Now, if the metadata changes in between, and these changes can happen if a referendum is voted in and the structure of the chain changes, a palette is removed or added, some parameters have changed, or maybe even some types inside the code, like representing account balances with a 32-bit integer versus a 64-bit integer. All of these changes are described in the metadata. And since the only way to update the chain is to submit an extrinsic that contains this new runtime, that new runtime will also contain the new metadata. And so when you reach a block in which a new runtime was proposed, you will not only get that new runtime, you will also get the extrinsic containing the new metadata that you need from that block onward to continue successfully building the chain. So the chain is kind of like building itself using only these extrinsics. Now, this takes forever. So this is a very slow process. And it's usually quicker to sync a full archive node from scratch right now on substrate-based chains than to rebuild an archive node from a full node. But it's important to know that it's possible, so that when people say, like people have been saying on Twitter about Ethereum, that since there are no archive nodes, I mean there are maybe 5 archive nodes in total, since there are almost no archive nodes of Ethereum out there in the wild, no one can be 100% certain that the blockchain is uncorrupted and that the total supply is what it says it is, and so on. Untrue. Every full node of Ethereum can become an archive node. It's just very technically difficult because nobody has 5 terabyte SSDs at their disposal. Same thing in Substrate. Every full node can become an archive node. It's just that right now, while the state is still small, I think Kusama is at around 200 gigabytes. While the state is still small, there's no point in doing that. You can just sync with the archive node from scratch. And when it becomes too big, we will of course have some contingencies to reduce the state size and so on. But in time, it will also become more expensive to run an archive node for a substrate chain, especially when parachains arrive. So when people start saying that this is unreliable because nobody's running archive nodes, keep in mind that this is not true, because every full node can become an archive node and verify the whole chain without connecting to a single other node. If your full node has the latest state, so it's synced with the chain, but it's just a full node, it can become an archive node even if you disconnect it from the internet. So it'll just replay everything it has, it'll build that archive for you, you will end up with a huge database, and that's going to be verifying the entire chain from Genesis. So to drive that point home, let's assume in this case that x is the result of a factorial n. So this is the formula, right? So you get x by multiplying all the numbers up until the number n. And let's assume that every block in our blockchain is one such value. So block 1 is 1, block 2 is 2, block 3 is 6. And so on. Block 4 is 24. So this is how you calculate it, right? This is the factorial. Okay, so for light clients, light nodes, let's assume that a light client wants x at block n sharp plus 1. So n sharp is anything that's less than the current block, and that's given to our light node. Now the light node has a runtime, which in our case would be the factorial in this example, so the formula for the factorial. Let's assume that's the runtime. And light nodes do have the runtime. So light nodes only have the runtime and the ability to verify something given to them by the full node. So in this example, our n sharp is 3, so that's the third block, and the value at the third block is 6. And so we are interested in finding out the value at the next block. And since we have the factorial, it is very easy for us to find out that the state at block 4 is 24. And then the light node will just discard the state that it just discovered to stay light. So because you can't really expect to store the state in a browser-based or a Raspberry Pi-based, not even Raspberry Pi can handle a full node, but like maybe a little, I don't know, USB stick computer-based node, or a kiosk-based node, you want them to stay light. So they will discard what state they don't need after they've done serving it, after they're done serving it to you. For full nodes, we have n, so the final number of blocks, and we have x. And we can at any time check that x is n, the factorial of n, because we have the formula, we have the runtime. We know that it's a factorial, and we can always calculate this. It'll take a while for us to get from 1 to n, but we can check this out. And archive nodes, and those are by default activated when you run a substrate chain in dev mode, because dev mode will, as we'll see a little later, developer mode will produce blocks in your substrate-based chain. And anything that produces blocks is actually a validator, whether it's a proof of authority consensus or proof of stake, or even the just instant seal method that the developer nodes use, or whatever. So any node that produces blocks is a validator. And for validators, archive node is default because they need all the past data to be able to keep in sync with everything. There is some research underway and some proofs of concept where these validator nodes can work with less than the archive node, but it's a little risky in cases where finality stalls. I won't go into the details of that. So in a nutshell, archive nodes know the answer to what was X at block 3. They know it's 6 because they stored all the states. They stored the state at block 1, they stored the state at block 2, at block 3, and so on. They know exactly, and when you ask them, they are immediately ready to fire back with an answer. But full nodes, they just need to recalculate from n equals 1. So in full nodes, you can also ask them what was X at block 3. You can ask for your balance at a block in the past, but a full node can't tell you outright. It has to calculate this. So it has to rebuild the state up until that block by following extrinsics, and that's all there is to it. So a full node becomes an archive node by recalculating from Genesis. It uses current state's justifications to build the chain and avoid forks. So because it has to be synced with a current full node, and then you can unplug it, it knows, because these justifications, these finalizations are also written in the past states, and so are also written in their past extrinsics and in the current state. And so the full node can follow those to build the chain and even avoid the forks that happened in the meanwhile. It replaces extrinsics and applies metadata as needed. And so that's it. So what is state exactly? How is it stored? State is current events, current values and events. So a substrate blockchain's state stores current values, and it stores events of that current blockchain. But the state is not past values, is not past events, and extrinsics don't fit into this. And RPC values also, those are node specific, as you'll see. Actually, we'll demonstrate a few of those. So those are node specific. So you need to keep in mind what you're actually searching for when you're querying for data. I think this is the last slide, yeah. So when you're querying for data from substrate-based nodes, you need to know exactly what you're looking for and what kind of a node you need. I would recommend always using archive nodes just because of the ease of access. They're not that big right now, and they just give you way more leeway into developing any kind of tool you want. But let's take a look at some of these values. So this is Kusama. And on Kusama, I'm going to go to chain state. So chain state is the current state that we have right now. And chain state is divided into storage, constants, and raw storage. So raw storage just reads these things in raw format in bytes. But storage and constants are what we care about. So storage, we can select here the module that we want to check out. So the palette that we're interested in. And let's pick an interesting one. Let's pick the society, the tattoo thing, right? And we can check out which bids are currently active in the society. You can see here that we now have all of the bids listed. And sure enough, this is mine here. So I have a deposit. You need a deposit to make a bid. And the value of my bid is 999 KSM. If society ever gets to 999 KSM and nobody's ahead of me, I will in fact get a tattoo. So these are the bids in the current palette right now, in the current state. But we cannot find out the bids from the past from the chain state of a full node. We have to use an archive node. We also have, let's see, some other ones, like for example, the Treasury. So we have here bounty count. Let's see how many bounties we've had in the system. 1. So the system has had a total of 1 bounty so far. This is because this is a new mechanism for paying people to do stuff for the blockchain. The council will approve a bounty and earmark some funds for future spending. They will then assign a curator for that bounty, and the curator can find somebody who will execute that bounty. and the curator is then in charge of distributing the payout. It's kind of like Gitcoin, but built into the chain itself. Let's look at another one. Indices, accounts. Okay, so you can put in here account index for any kind of index, and I think, okay, there we go. So this is empty. This is an empty. This address is assigned to index 0. If I put in 1, let's see what happens. So okay, this account is assigned to index 1. I think I can also do. Hold on. No, this is not here. Okay, never mind. So in constants, let's look at some other values. Constants are things that are that don't change. So storage will change based on extrinsics. That's going to change. But constants will not change. These are defined. These can be changed by referendums, by through governance. If you submit a referendum, change something, but they cannot be changed by state changes, by extrinsics. So for example, in Treasury, the burn rate, so every spending period, which is every 7 days, every 6 days, is a spending period. And whatever isn't spent in that spending period, whatever remains in the Treasury, will get burned. So next burn is 460 KSM. This encourages the Treasury to be fully spent every spending period, so that we want to fund the ecosystem. So if we go to our chain state constants and select Treasury, we check out this burn rate. You can see here that 0.2% of the amount that's being that's unspent will get burned. The trick here, the caveat here is that, and that's not explained here in the UI anywhere, is that this 0.2% of the Treasury that would actually get burned actually gets redirected to the society. So the society's pot is growing through the burning money of the Treasury. That's the only way it can automatically grow right now. So the chain automatically funds this society. But this constant is set in the code, and it can be changed through a referendum, but it cannot be changed through storage. There's no way to update this value. Block hash count 2400. Okay, this. Let's see if there's any other interesting constants. Anyway, so these are the constants of. So this is the existential deposit, for example, in the balances module, and this tells you how much KSM you must have in your account before your account is deleted from the state to save space. So this is another space saving mechanism where if your balance drops below this, your account will be reaped or destroyed, deleted from the network. So, and these are the chain state and the constants, right? But we also have, so extrinsics can be submitted manually through this thing, doesn't matter. But check this out. So we have here the RPC calls, and these RPC calls go directly to the node. And now, let's check these out. So get block hash, and if I click submit RPC call, I just got the latest block of this chain. So 4745253, 4745255, it's already. So this was the block when I submitted it. And I get all the information about the block in this value at that point. But I can also include the option of which block hash. So I can also include a manual block hash in here to get the data of a specific block in the past. And this is possible because this is an archive node. Now, generally, full nodes will also keep 256 blocks of state behind. So you can actually, with a full node, you can also go 256 blocks into the past. But this is the RPC call that lets you go into the past in terms of getting block information. Let's see some others, like state, get metadata. So now we have state metadata, and this is the metadata of the chain itself. If I leave this empty, that means I'm interested in the current metadata at the current block. So check this out. I hope this doesn't break the UI or the crowdcast. because this is a lot of information, right? And now in here, we have a description. Look at that scroll bar. In here, we have the description of the entire chain. So you see here that we have all the information we need to grow the chain. Here's an example. Let me find something. Okay. Technical membership. This is for the technical committee part of the block. I haven't covered that, so I'm not going to go into that. Okay, this looks like the treasury. Yeah. So this is a treasury. And we have here several items are defined, proposal count, documentation about it, number of proposals that have been made. So you can see that everything is documented. Proposals that have been made. So this is just a number of proposals. These are the actual proposal items. Approvals on those proposals, tips that have been submitted, and then you have here the description. So everything that's in the code is turned into this metadata and output using the RPC call state get metadata. And this is how different UIs can actually read this metadata and modify the UI based on what was given to them. You can check this out for any chain that's supported by that's Substrate basically. All of them have state get metadata. So let's see here if I can do it like this. So now we can go to Explorer and let's go to block 1 million. 1 million. So the block, okay. Okay, let's go to this block and now we have the block hash. Let's try to get the metadata at that block hash. RPC calls. Get metadata. And now we have the metadata at that block. And if you compare it, we're not going to do that right now, but if we compare these two metadata blocks, they will be different because there have been several runtime changes in the meanwhile. Several upgrades to the chain have happened since block 1 million. So these two metadata items, these two metadata blobs will actually be different. And so when the chain is rebuilding itself from the full node to the archive node, it's going to rely on these changes in metadata to actually keep building correctly, because it could break if it doesn't build itself correctly. The Polka.js API that we can use for all of this. So this is the API that we want to use for this. It's Polka. Let me share that in the chat. So this tool is what lets you interact with the nodes in a very intuitive way, and it will automatically switch out the metadata for you. So if you try to iterate through some blocks in the past of a blockchain, this API will grab the metadata at that block whenever it was uploaded, and it will apply it so that the code that you're writing can still interact with the chain. What can happen if you don't do this is that, for example, you have a script which goes through historical blocks to find your historical balance and draws you a graph of how your balance changed. But at some point in the past, the representation of balance in the in Kusama changed from a 32-bit integer, a 32-bit integer to a 64 one. And so what you get from that is the API will break when it tries to read before that change and after that change, because it can no longer recognize, because this is TypeScript and it has types, and the type of your balance is defined in those bytes, right? And so if it tries to grab an old value using the old type, it'll work, but if it tries to grab the new value with the old type, it'll break. And so you have to reapply the metadata in between those changes so that it also gets the new type applied, and then you can grab the newer data with the newer type. And so this tool is what you want to use when you're grabbing data from a Substrate chain, so that you can work without fatal breaks in your code. So let's try and get a simple script up and running, which will fetch some extrinsics or events or something, whatever we have time for. To do this, we're going to be using Node.js. And oh yeah, I recommend that you don't test this on live chains, but instead that you run a local node, which will let you play with things locally without needing money to submit transactions, right? You want to write random things to your blockchain. You don't want to spend real money to do that on the live chains. So what's easiest is to do, go to parity text / Polkadot. What's up? Okay. Go to this repo and then find releases. And so you can click on the latest release, and every release is going to come with a binary that you can download. That's the 68.6 megabyte file here. This binary can run on the Windows subsystem for Linux or on Linux itself. If you're on Mac, tough luck, you will have to connect to a live node. We do not distribute binaries for OS X yet. I don't know why. But this should work on any Linux distribution. You just download it and that's it. What I have here is a version of 0824, so I downloaded a release one older than this.
You could
Doesn't
also
matter,
build
it's older.
and compile your own chain, right, and run this on your own chain?
Yes, I mean, you can just clone this repo as well. You don't have to go to releases. You can just clone this. And there are instructions here. So you just clone this, you install Cargo, you install Rust, you install the prerequisite tools, and then you run Cargo build release. But this takes a very long time. If you don't have a powerful rig, this can take something like 30 minutes. For me, it takes 10 minutes, and I'm on a fairly powerful rig. So it's not exactly very accessible.
I could say it's worth it though. For a learning experience, it's magical once you're like running your own node and you can make like live runtime upgrades and stuff like that. It's super cool.
Agreed, absolutely agreed. So if you go to substrate.dev and tutorials, let me share that URL. So if you go here, the first 4 tutorials will help you compile that node locally. It's not going to be Polkadot. So this thing that I told you to get is actually Polkadot itself. So if you download that and run it, you will get all the palettes that Polkadot has. These tutorials will help you download and compile node template, which is a much more lightweight node that doesn't have almost any of the Polkadot palettes. It's super bare bones. It is intended to be a base for you to build your chain on. So the node template is meant to be extended into your own chain. Polkadot itself is the production chain. Over here, I'm using the release of Polkadot. You can use the release of node template or just follow the tutorials to do this. It all works. These times are misleading. 1 hour, 2 hours, 1 hour, 2 hours. The whole 4 tutorials at the beginning take 2 hours total, all put together. So please, I encourage you to do this. It's worth it. So I have here the downloaded Polkadot 0824 binary, so I can just run it directly. And if you have yours, feel free to follow along. You run it by just Polkadot and then --dev. --dev is important because it will run the chain in admin mode, which will automatically seal blocks. If you don't do this, it will keep waiting for another node to connect to it, another validator node, and so that they can start producing blocks together. And you're not going to be getting any blocks. You also will not have any funds in your accounts on your chain, which is less than useful for testing. So by adding dev, it will not only produce its own blocks, it will also unlock some accounts for you for playing around with. Let's take a look at that. So this is running now, and highest known block is at 0. New epoch 0 is launching. Imported block 1. Okay, it's working. This looks pretty ugly because my terminal emulator does not support UTF-8 emojis. In yours, it will probably look really pretty because it's all full of colorful emojis. let's check this out. When your chain is running locally on your computer, you can actually connect to it from the hosted live version of Polka.js apps. So let's do that. Development, local node, and switch. So in the top right of polka.js.org/apps, you have the option to pick networks. You just go to development and click on local node and then switch. That's it. So if I go to Explorer, you can see here we are on block number 8 and it's building the blocks. Alice Stash is producing these blocks. That's one of the unlocked validator accounts that are automatically added into my blockchain with the dev option. You can check this out on accounts. You can see here that Alice has 1,000 unit, Alice Stash has 1,000 unit, Bob has 1,000 unit, and so on. And then there's all the other accounts. So we have here some accounts with unlocked balances, and the blocks are growing. They're being produced. That's great. This works. Now, let's try and read some events from some blocks. In fact, let's create an event, and let's try and find it later. First, we'll go to extrinsics, and then we are going to make... Now, if you were in the previous webinar, you will be familiar with this, but if not, there is a tool that I built. So because Kusama and Polkadot do not support smart contracts, it's not really possible to have any tokens on it. That includes non-fungible tokens, NFTs. And so because I wanted Kusama to be able to play with NFTs sooner rather than later, I opted to hack NFTs into it by force. And the way I did it is I used the... Where are you, Alice? There we go. I used the system remark extrinsic, which lets me graffiti the chain. The system remark extrinsic just lets you output or input any message into the chain, and every node connected to this chain will see that extrinsic. The remark itself has no effect on the state. It doesn't change anything in the state. It's just something like literally putting graffiti onto a block. So if I put here 0x1337 and submit this as Alice, block 29, so at block 30 this will be included. There we go, block 30. Let's check it out. Network Explorer, let's see block 30. There we go, system remark. So you can see here that my extrinsic for system remark has been published in this block. And you can see here that there's a matching system extrinsic success event. So this is an event that matches my system extrinsic. I used this method to build remark app. So remark will use these remarks to formalize messages like these, put them into remarks, and then every node that reads such a message can interpret it to basically get an NFT out of it. So by using this, you have NFTs forced onto Kusama. But the caveat is that this requires processing the chain from the beginning, because we need to read all of the extrinsics that contain these remarks. We have to treat every node like an archive node. So when you're doing this, you have to read all the extrinsics from the start, because all of those remarks are written in blocks that may have occurred in the past randomly. Like it's not uniformly distributed. Like maybe a remark is going to be on block 100, then another one on block 2005, and so on. So you need to process all of them to be aware of when each remark was issued. And this is one of the problems of state retrieval with chains in general, is that if you don't have a on-chain structure into which you can store changeable data, mutable data, like a smart contract, then it becomes quite problematic to build stuff like this, which is basically inspired by colored coins from Bitcoin, which use the same method. So they used the same method of graffitiing the chain to get tokens onto Bitcoin way back in the past. You can read this on rmrk.app, so remark.app. in general, this is how it works. And this was one of the active problems, still is one of the active problems that I'm working on in terms of data retrieval and indexing. Because we have these remarks, we need to be able to get them all, categorize them, and not just have a list of all of them that happened, but also know which remark has caused which effect on another remark in the past. Because if I have an NFT and then I have a special message, a special remark that sends that NFT to a certain user, then I need to apply that to my previous knowledge about that NFT. So in a way, I'm building my own archive database of the remarks that I'm publishing using this system remark thing. Very tricky stuff. Anyway, we know that in block 30, we have the remark 0x1337, and we're now at block 63 already. But since we're running in dev mode, we are not going to lose this information when blocks go beyond 300 and something, so beyond that 256 block cutoff range. We know that this is going to stick around. So let's try and read these extrinsics, blocks and whatnot. I'm going to start a new project in Visual Studio Code. Actually, let me first fire up something new here. So you can follow along if you want. So let's make a new directory for Crowdcast demo. I'll initialize a new JavaScript project, that's fine. And then we can just add the Polka Dot API. So this is how you add it. Add Polka Dot /API. It'll take a while because there's a lot to add. It's not exactly a small package, especially because of the crypto dependencies. There we go. Now it's in. And maybe we can do source and touch source index.js just to have an entry point into the app. Now let's open this. Okay, so now let's open this in Visual Studio Code. Let me just fire up a new window. There we go. CC demo. 1 second, I lost my chat. There we go. Okay. Wait, what's up with this? Hold on, I think something's not right with the cache here. It's not seeing any files. Let's close this window and reopen. Sorry about that. It's Visual Studio Code acting up. Never do live code demos, kids. Okay, Visual Studio just crashed, so I'm gonna revive it. Hopefully it'll be fine. This is fine, this is fine. New window. One moment, ladies and gentlemen. And no, it flat out refuses to show my files. Doesn't matter, we can just cowboy code it. It's fine. So let's go like this, old school way. Alright, so our entry file needs to be able to initialize the connection to the blockchain that we're using, right? So if you're using the live chain like Kusama or Polka Dot, you can connect to those. If not, you can connect to your local chain, which is in my case still running. So we'll do this. API is require. So we'll require Polka Dot API, And then we're going to put it like this. Test function, and then we're going to call the test function here. And we're also going to do, let's first test this part to make sure it works, because I'm not used to coding like this. All right, we're good. So now we need to create the instance of our API connection. So we'll first create a WebSocket provider. That's going to be this provider. So we need to get it from, we actually need to instantiate this. And we are going to add in the endpoint that we want to connect to. So like I said, in your case, if you're using the live chain, connect to the live chain's endpoint. That's going to be WebSocket secure, and that's going to be something like RPC Polka.io, I think. And for Kusama, it's going to be Kusama RPC. I don't know. It's in the Polka.js UI. In my case, it's going to be 127.0.0.1.9944. That's the default port on which your node is running. So then we'll create the API instance. That's going to be something like API promise, and then we're going to create this with the provider that is the WebSocket provider. So without autocomplete, I'm sure this is full of typos. We'll see now. No. Let's check it out. All right, looks like it works. It looks like it works. I forgot to put in the process exit, so it keeps waiting for this asynchronous function to finish. So that'll do it. Yep. Okay. So now we have the API connection defined, and now we can ask it for some event information, and we can actually actually let me show you an RPC call first, right? So let's if we go to, where is our RPC calls? We have here chain, and we can get the get header call, and we actually get the header of the last block, so just the header, and we can turn that into the number. So this is automatically turned into a number for us. It actually comes as bytes. So this is how you get the number of the latest block. What is this folder? Hold on. Trying to revive the Visual Studio Code so it's easier to code, but it is disobeying. Anyway. Where was I? Oh yeah, this. Okay, so if we want to get the number of the latest block, we first have to get the block header. So we do this, and so Polka.js API is all promise based. It's all based on awaiting calls to finish from JavaScript, right? So we'll do it like this. So we'll say await, because we are in an async function. We can do this, it's no problem. So we'll await for a return from the RPC, and we know that it's in the API instance, and that's going to be, so every time you query RPC calls, you use the RPC endpoint, and then you just list the module, the palette, and the function that you're interested in. So that's going to be chain, and then it's going to be get header. This is what we just did in the UI, right? And so we now have the header of the chain. So if I just go to console log header, header, and then you can see here that so chain get header produces an object which has the property number. If I do just number, and try to echo that, you'll see what happens. So it gave me a type registry. So it doesn't automatically convert from the raw data of the chain to something human readable, because this does. The UI is configured to do these automatic conversions, but the raw data is still raw. So we need to turn this into something human readable, and that's done with toNumber. And by calling toNumber, we should get a number. There we go. So we're block 158, yeah. Okay, so this is how you call information from RPC. But remember, RPC is only the current data that is served by the node. So let's try and find some, let's actually delete this. Let's try and find some, events, okay? I wish this thing worked. I've never had Visual Studio crash this way. That's a shame. Anyway, let's do this. Sorry, I'm improvising. Let's define some blocks that we are interested in. Something like, I don't know, block. Okay, let's see block 30 for now, just block 30. And then we will iterate through our blocks so that we can actually use more of them later. So we'll iterate through all of the blocks that we want to process. And then we are going to grab the events and extrinsics of each block in our desired list. So this is how we'll do it. First, let's delineate a little bit so that it's clearer to read. Processing block B. That should be fine. Now let's grab those. So first we need the hash of our desired block. We know the number we want, but we don't know the hash, and everything works through block hashes here. So we'll get the block hash by awaiting an, again, API RPC call to get block hash. This is a function that takes a number of a block, so like this. And you can also see this, get block hash by block number. So if we do this, put it at 180, we have the hash of block 180. So this is a function that's built into the chain palette. So we'll use this to get our block hash. Then we can grab the events by using another call, but this time we're going to use the query endpoint, which means that we go like this. Now when you use query, you're querying the state. So why are we querying the state when we want to grab events? Well, because events are part of the state. When a full node prunes the state to be a full node and not an archive node, it deletes events and past states. Because events are part of the state, they're automatically deleted when the state is pruned. So events become a part of the state when they are emitted. They become a part of the state. And so to get them within an archive node, and we need to fetch things in the past. And how do you do that? You do it by querying system events. And there's a helper method in Polka Dot API that's used like this, @. And so if you provide the block hash into @, you actually get the events at that block hash. Let's try that over here. So we have here chain state. So remember, we're using chain state because we're now using query. If we were using RPC, we'd go to RPC, but chain state is query. So we have system and events. And now these only let you search for events deposited of the current block. And now you will see the events in the current block. So there's no add functionality here. This add functionality is completely a part of the Polka Dot API. It wouldn't be hard to add it here, but the author of the UI just didn't do it because this is entirely a programmatic thing for people who use blockchain explorers and the like. And so now we have our events, and we can check how many events we have found. Console log, something like found blah, events and block blah. Let's see if we get anything useful. I keep clicking Control S to save and messing up. So now I broke something in here, I think. Come on, man. Yeah, it looks like I broke Vim. Amazing. Come on. Okay. Dude, seriously? Sorry, kids, never do live hacking. I broke 2 IDEs now.
This is amazing, though. Like, yeah, doing live coding and just rolling with the punches of technology not wanting to cooperate.
Amazing. Okay, let me do one more experiment here. I'm going to do it like this. I'm going to open a new tab. So this is Windows Subsystem for Linux. It might also be responsible for this mess. So let me do it like this. This is probably not going to let me copy it, but oh, all right. Now let's try this new window. Come on, roll dice, and no, okay, yeah, it's not loading for me in any form. I think there's something up with this hard drive or the way the subsystem communicates with the top OS. So I guess, yeah, this is not gonna work. I'm sorry. Sorry about that. I will make it up to you with some tutorials. If you would like to learn how to do this stuff that I was going to do and more, you can go to .leap.com because we're kind of out of time at this point and just really wanted to demo this. So at .leap.com you have a bunch of tutorials that will show you how to fetch data from the chain. And you will fetch anything from identities to events and extrinsics and so on. And we've got a bunch of other tutorials in the pipeline so that you can really learn how to interact with the chain in your own way. What I did want to bring up in the remainder of this webinar was the problem of grabbing. So the project that I mentioned a little while ago, the remark thing with the system remarks, you can imagine that as, if you want to keep it decentralized, you have this one UI, and this one UI, when people visit it, it'll fetch data from the chain, and it will rebuild this index, this archive of remarks for you, and it'll know the state of the NFTs. But you can imagine that as the chain grows, as it expands, as it gets bigger, it'll take longer and longer and longer to get that archive state. And especially if the user just is a new visitor to the page, they will have to rebuild from the get-go, from the genesis of the project, and get all of those events and then reconcile them. And only then will they be able to use the project once everything is reconciled. And so it's very difficult to make this both decentralized and user-friendly, because if you make it decentralized, then you can't store past data anywhere so that people don't have to rebuild it from scratch. But if you make it centralized, then it doesn't make sense. And so one solution that I came up with, and then I would like you to task you with thinking about and brainstorming and getting in touch if you get any interesting ideas, is you would, and this is something that I'm working on a proof of concept right now. I initiate the rebuilding of this archive, and every X blocks, which in my case is every 50,000 blocks, I will compress the results of that archive, turn them into an IPFS file, and put them on IPFS. And so when a new user shows up, we will build these IPFS hashes into the library for interacting with NFTs itself. And so the library will be aware of these hashes. So when the library is first spun up, it will connect to a blockchain, then it will find these IPFS hashes. Then it will try to fetch them, and for every hash that it cannot fetch because nobody is seeding it or because it's missing, it will rebuild that section. So those 50,000 blocks it will rebuild. And then it will merge with everything that it did successfully fetch, so that it gets one full complete picture. And this is much, much faster. It still takes a few minutes, but it's decentralized and still much faster than rebuilding from scratch. The problem there is incentivizing people to keep those IPFS hashes pinned. I keep a few pinned. I'll pay for some services to keep them pinned, but this is not very hopeful for the long-term future of the project if nobody's really, encouraged to keep them pinned. So I'm interested in if you have any ideas on how to approach this storage problem, on how to approach this refetching problem, this re-archiving problem. I'd like to brainstorm with you and see if we can come up with anything. And also, if you want to interact with any of this stuff in hopefully a more stable way than I just showed, please go to .leap and check out the tutorials. I see there's a question here. Question on custom RPC queries. They use std and do not appear in metadata listing. Does this mean they're outside runtime upgrade and the only way to update them is via node update restart? So yeah, RPC queries are not in the runtime itself. So RPC stuff is node stuff, is purely binary node things, binary node stuff. So the only way to update them is via a node update and restart. So RPC nodes, RPC endpoints are something that you have to do a hard fork for, that you need to update your actual software to get the new endpoints. Yes. Before I dash, are there any other questions? Remember, let me just pull up the contact information. You can always get in touch with me at these resources, and the newsletter is at newsletter.leap.com. If there's no other questions, I will close it off here and promise to make it up to you with some awesome tutorials on .leap. Sorry about the technical difficulties.
No worries. It happens. We're used to it at technical events. It always happens. But I think we had a great chat with you to kick things off, and you had a great talk and a great demo. And like you mentioned, we can follow up with the tutorials on .leap. So I think that's a great place to jump off from. So thank you very much, Bruno, for tuning in and giving us those knowledge bombs. Let's take a quick look at our polls. We introduced a bunch of folks today to .leap, and so they're going to head over and subscribe. And we had quite a bit of full node runners here. It was almost 50-50, but more in the favor of full node. So 57% of folks run their own full node. So that's very encouraging to see. I'd like to see that number continue to grow as we move forward. So thank you very much, Bruno. If you have to jet, we understand. We will see you in the near future. Hopefully you'll come out and give us another great talk for our next hackathon. But to just kind of tie everything together, folks, it is still not too late. I forgot to put the link to our portal, but I'm going to put that in our chat right now. It's still not too late to sign up for Block Hack. Our final submission deadline is November 6th. So you still have a few days, and you'll be surprised how much you can actually build in a few days. Normally we've done these over a weekend, so like Friday to Sunday, and you're already presenting a couple days after you've begun. So you'd really be surprised how much you can build in the next few days. Particularly, we also have bounties for people that don't have a technical demo. So if you have a business idea, a business plan, bring that forward, make a pitch deck for it, make a compelling argument for it, and you can get some funding to continue your project and idea. And of course, if you do have a demo, that will make you eligible for the seed funding round. So there's still a couple pathways that you can jump onto, and it's not too late. So head over to portal.blockhack.ca. You'll find the links to sign up and the links to get into our Discord. And once you're into the whole flow of things, we're there to support you for the last kind of push as we close out this amazing. It's been a roller coaster of 6 weeks, 6 week long hackathon and conference, and it's been amazing. I also want to drop links for. So this is the direct link for the hacker resources. So in our Discord channel, you'll find all the hacker resources that you need to get your submission in, and you'll find out what the judges are looking for. And just so you have it here, I will drop the link for the sign up for pitches or for judging, and there is a Loom video, very helpful Loom video, letting you know what prizes are out there and what you can expect from the whole judging process and all that fun stuff. So you're not going to want to miss out on this opportunity to start your journey into building a business in the blockchain space. It's not stopping here. This is only the beginning. It's a very early space, and you're getting in on the ground floor. So you're not going to want to miss out on the acceleration that can happen from getting some seed funding here, making these connections, starting by taking the first step during this hackathon. And we're here to support you to the end of this hackathon and beyond. That is our mission. That is our goal. So I want to thank Bruno again for being here and giving us this great talk, giving us some great things to think about. And I encourage you folks to subscribe to .leap and follow Bruno's transparency mission on bringing you the information you need and supporting him on his in his council position. So again, thank you, Bruno, for being here. And thank you all for tuning in. I will see you in a few more hours. We have our final workshop for the conference. I'm super excited, a little bit sad, but this is not the end. It's just the beginning. So I will see you guys in a few hours. And until then, I'll see you in the Discord, and I'll see you in the next workshop. Okay.
Thanks.
Bye, everybody.
Bye. Pleasure.
Take care.